Hi everyone. I'm going to make a short video here on the Network Prediction Insights tool that I've been working on lately and was recently checked into UE4 main. This did not make it into 4.2.5, but will be in 4.2.6, and we'll start to see more systems use this in the engine soon, hopefully. I'm not going to go super deep into network prediction itself. I suggest reading the README file that's in the network prediction plugin and checking out the network prediction extras plugin for some sample content if you want to get an idea of what this system is trying to do. I just want to give a kind of a quick overview of the insights tool that I've made. But with that said, I will real quickly just go over the steps for how to actually enable all this stuff that you're going to see right here. So first thing you need to do is enable the three plugins right now. There is network prediction extras, and network prediction insights. I've enabled them through my .u project myself, but you can enable them through the plugin manager in the editor if that's better for you. And then I'm running with -trace equals np on my command line. This will enable the network prediction trace channel by default. That way you don't have to manually do it through like trace data filters. Okay, so I'm logging. I started the editor here, and I'm going to open up one of the test maps. To do that, I'm going to go make sure that you have show engine content and show plugin content enabled, and then you should see the network prediction extras folder in your content browser. So then under maps, you can open up. Actually, I'll start with test map empty. We'll just do a really quick one actor, one client view of things, just to kind of get our head around this. Okay, so then finally, before I start, I'm going to launch the Network Prediction Insights tool, which is currently under Window General, though that might end up moving at some point. But yeah, so it's right here right now, so it's empty because I haven't done anything yet. I'm going to pi with one client, pi ets client with one player, and this will just really quickly give me this. So this is my little spaceship guy. He can do some kind of ability things. Like so, and then I'm gonna do a couple of force corrections. I have a console command bound to force a correction, and so I did that a couple times so we can just see what it looks like. So I'm gonna press escape now because that's all we need to trace, and then we're gonna go over here and look at what we actually traced. So this is a view right here. What we're looking at is this is the simulation timeline. This is what the simulation was doing in the sort of the course of its lifetime. This does not necessarily map to real time. As you'll see, that the simulation timeline can evolve sort of non-linearly with time. Sometimes we roll back and resimulate time in the past and catch up and that sort of thing. And at any given moment, the client and the server, though they might have like be sort of together in real time, they're not necessarily in sync with the simulation, and the simulation timeline is what kind of shows this. So just as an example, like right here, these two bars are flying drone. The top one is the server, is the authority. The bottom one is the client, the predictive controlling client. And so at this moment in time, this engine frame 20827, the last engine frame that we captured, the client has actually simulated ahead of what the server has been doing locally himself, and so the simulation timeline kind of like shows this. And then so the cool thing too is that you can step back too. So this was like the state of things at the last engine frame, but I can press this button, or comma is the shortcut key, and I can press this to kind of like walk things back. And so let me back up to and explain that these boxes here that we're looking at now, so these represent actual calls to a simulation tick. Like we actually called our core simulation tick function. Here's one for the parametric mover, but maybe the ability one is a better example. Yeah, this guy. This is like kind of the core of the whole network prediction system. It's this simulation tick function that takes a time step and like discrete set of inputs and outputs, has no side effects, and this is like what we're networking. We're networking this thing ticking at various intervals, and we're keeping the inputs and outputs in sync between the client and server. We're predicting them on the client, and that's what this thing's all about. So this represents, one of those ticks, and you can mouse over or click and see all that input and output that I was just talking about. It tells you, what the engine frame was, what the simulation frame number was, what the simulation time, what the time step was, what the inputs were, what the input command was, what the input sync state was, what the input aux state was. That's basically your actor game state that we're synchronizing here, and then what the output was, the output sync state and the output aux state. And in this case here, the output aux state we didn't actually write to the auxiliary buffer here in this particular tick, so it didn't actually change, so that's why it's gray. So these boxes represent ticks, and these other marks, the markings right here and like right here, those represent network receive points. So this is where on the simulation timeline we received a network update. So every bunch that this system sends, it's time stamped with the local that simulation. It sends an update on that simulation. It says this is where the simulation was at this simulation time. So as an example here, this is the last one. This is the last update that this client received from the server, and he received it at this frame. This is a new thing. This is a new. We didn't have the frame before. If I back up one, like this, that tick wasn't there. We received it on this frame right now, but the client was up here simulating predictably, and he's receiving updates in the past on the server. And this is where on that simulation timeline that update actually corresponded to. And so what you can see here happened, if I kind of just go back and forth, is we got that network update, and since it's green, green essentially means that it was a confirmation frame. It was an update that we processed, and it did not cause us to correct or roll back our local simulation. We just said, okay, we're good. We can just keep predicting forward. We don't have to rewind and reconcile anything. So the tick mark itself is green, and then everything to the left of it is green, because we're sort of guaranteed now at this point going forward that we won't roll back the simulation prior to this confirmed point. So everything back here is now confirmed, and everything forward here is still predictive. That's what the blue means. So let's kind of scroll back then and go to a point where we actually had a correction. We can kind of just real quick look at and see what that looks like. We'll go to this one. So the way the tracks get drawn are it's just kind of opportunistic. It tries to fit things in wherever it can, but also keep continuity. Excuse me. It tries to keep continuity, so we don't sort of jump up and down unless the simulation actually was actually rolled back or skipped forward and broke continuity itself. Okay, so let's look at this block right here. This was a correction that happened. So what I can do is I can click here, and I can jump to this point, jump to this engine frame that this simulation frame ran on. So I do that, and so now that tick that I just had right-clicked on is now flashing. So this was the frame that it was actually new on, and at this point it was a blue frame. It was a predicted frame. We didn't know that it was going to get corrected. And if I step forward one, you see there's still a predictive frame, and I step forward one more, and now we get the correction. Now we see that the correction happened. And so a lot happened this frame. We see all this stuff has this pulse, this glowing pulse to it, which means something changed this frame about this tick, or this we got this network receive. And so the thing that instigated all this was this network receive point right here. And we actually can click on this. If we click on this simulation tick, in addition to the simulation tick information that we have down here, we also have what was in that network receive. And in this case, it's the state, and this state was committed. If it's a confirmed frame, for example, if I click here, it's uncommitted because it didn't actually get committed into our local buffers. It was just used to verify that our historic buffer was correct. So so this network receive here caused us to roll back the simulation. That's why it's red. And then all these frames up here that we previously had predicted, or that were previously blue, they became trashed. They became red because we rolled the simulation back prior to them, and they're essentially going to get overwritten. in the runtime buffer, in the trace analysis buffer. They're still here. We still always have a copy of those things. We don't trash anything. So yeah, so these all went red, and then we have a solid line of purple here, which it looks similar, but they're not blue. Purple is means it was a resimulate. It means it was a catch up to where we had previously been. And in this case here, we did these all in one frame. So if I click on this, for example, this engine frame was 20660, and as I mouse over them, I'm seeing at the bottom of the mouse hover tip, it's the engine frame is the same. We did all these on the same frame, which is also because they're all flashing. That's how another way you can tell that. They're all pulsing, I should say. We resimulated these all in one frame, and then we did one more predictive frame for the sort of the new frame that we were ticking after that network receive and reconcile step. Yeah, so then that, and then these ticks right here, they all turn green, and that's sort of implicit. They implicitly were confirmed, because we're not going to roll back. Like, we roll back to this point. Everything prior to this point is sort of, in a way, it's a little wrong to consider them confirmed, because they could have been wrong. In fact, if I click up here on the server's version, I actually probably can find out which one it was actually wrong on. It looks like, yeah, for example, these ones look like they were off. If I'm looking down here at the sync state. So the actual divergence was probably right here on this frame, but the runtime doesn't tell that. It doesn't know that. The runtime doesn't detect that there was divergence until it actually gets this network receive point. So maybe at some point this tool can be like updated to either like find that exact point where things were diverged, or maybe there could be a mode you can enable, or something like that could happen. Or maybe these just shouldn't be green. Maybe these could just be like some ambiguous color, like we don't really know if they were confirmed or not. But I don't know, kind of a minor point. Doesn't really matter. Yeah, so I think that's a good example of just sort of what this lets you do. You can scroll around the timeline and see sort of how things evolved. You can click around and see exactly what the inputs and outputs were. At some point, what I want to be able to do is take the data here, be able to change it or re-simulate it, and send it back into the game, into the runtime game, and actually be able to like break points. So if I, for example, wanted to be like, hey, let's re-simulate this simulation tick, and I want to catch it in the debugger and step through and see exactly what happened. That's the kind of stuff I want to eventually get this tool to do, but currently it's just sort of a one-way communication. Yeah, I think that's pretty cool. The other cool feature to show is that you can search. So I can search the simulation states by it's just a string search right now, but it's actually quite powerful. So if I search for like B sprint press 1, so here were all the frames where I was sprinting around, and I can kind of click them and see that like a sprint was pressed and I was sprinting down here, and I can even look at my stamina. Yeah, my stamina was like 37 on this frame, and if I click a couple frames over, it's 35, 32, 29, so it's like decreasing. So I don't know, just kind of a neat tool to kind of just reason about this system and how things all kind of work. So I think this is a good stopping point for the kind of the first video that just gives a really quick overview of how to enable this stuff and how to use it and step through it. And I think this is probably good enough to get a lot of people started. I'm going to continue on though and make one more video that shows like multiple clients and multiple actors, and just sort of some of the more subtle interesting things I think that this system shows. So thanks for watching if you're still here.